Okay, so in the first part of this unit, we focused on angles inside of circles and outside of circles and inside of our circles, just everywhere angles. Um, and there were line segments that formed those angles, but now we're going to focus on more specifically on these segments inside of circles and that go outside of circles, just all the different segments and how they behave when they're with circles. So first of all, let's review what the sonata chord even is, since we're talking specifically about the segment chord today. Chords are segments that go all the way across the circle, and their endpoints are on the circle itself. So remember, a diameter is a special kind of chord. And so what it says is, note, the endpoints of chords are also the endpoints of arcs. So we have high here is a chord. This is a chord. And then we have the arc that is cut off, that part of the circle that is cut off from the rest of the circle by that chord. And same thing down here, bi is a chord. And then you have that part of the circle, that arc, bi, that is cut off by that chord. So theorem 10.2 says, in a circle or congruent circles, two minor arcs that's less than halfway around the circle, less than 180 degrees for a minor arc, are congruent if and only if, remember that means this goes both backwards and forwards to say if and only if, their corresponding chords are congruent. So what it's saying is that these arcs, high and bi, we could say they're, we'll do the degree measure is maybe 120, and maybe, but we know that these two will be the same. We can put tick marks on them just like you would a segment if their chords are the same length. If those segments that cut off that part of the circle are the same, if they're both like 10 centimeters, then they have to cut off the same amount of the circle if they're the same length. It's kind of cool. So this would also be like 120 degrees. All right, so here we go. Find the value of the variables. In example 1, we have two congruent circles. We know that they're congruent. We know that they're the exact same size because of that statement there. Circle Q is congruent to circle T, and it also tells us arc PR here is congruent to arc SU here. Okay, so let's see. I know that if my central angle is 120, then X would be 120. Remember, it's only half when the vertex is on the rim of the circle. They're the same amount when it's on the center. So then that means this over here would be 120 because the arcs are congruent, and if the arcs are congruent, their central angles will be congruent. And then I know this is kind of hard to tell, but that's supposed to be a W there, and W, if these are congruent circles, would be 3 because our radii have to be congruent in congruent circles. So basically, you're just matching up the matchy-matchy parts and saying that they're congruent. So pause the video, give it your best effort on the you try, and then we'll come back and check. Okay, so it tells us the chords are congruent, so we automatically knew that Z was 15. And we know because the chords are congruent, that's how we can say if this arc is 170, that this arc is also 170. Because the chords were congruent, that meant the part of the circle that those chords were cutting off had to also be congruent. I'm sorry, because the chords are congruent, the arcs are congruent. So if this one's 170, this one's 170, in which case the central angle Y is also 170. All right, let's look at the next thing. It says vocab review. The chords of adjacent arcs can form a polygon. So all it's saying is these lines that I have going across my circle, these chords, they can form a shape on the inside of the circle. If all the vertices of the polygon lie on the circle, then the polygon is inscribed. We've seen that word before. In this case, the circle is said to be circumscribed. So what's on the outside is circum, is going around or about, is what that prefix means. Inscribed, it's on the inside. All right, so that's great, Miss Mitten. Why do I care? Well, using our last theorem, now I have, well, let's read our instructions first. Determine the measure of each arc of the circle circumscribed about the polygon. So according to that last theorem, these are chords inside this circle, and if it's a rectangle, we know something about those chords. We know the opposite sides are congruent. And then our theorem said if the chords are congruent, then they cut off equal parts of the circle. That the arcs that go with them will also be congruent. Okay, so what we have to work with here, if we're going to figure out the measure of the arc, is we got to solve for x. And we know that there's 360 degrees all the way around this circle. So let's see, maybe if I scoot over here. So I know 4x plus 2x plus something is going to equal 360. And I know that this yellow arc is also 4x because their chords were congruent. And I know this green arc is also 2x because their chords were congruent. Because the green arc over here was 2x. All right, so all the way around the circle, I have all the arcs, so I can add them all up to 360. So 8, 9, 10, 11, 12, x. So if I want to continue to solve for x, I'm going to divide both sides by 12 to get x by itself, and so x 360 divided by 12 is 30. All right, but we weren't solving necessarily for x. That wasn't the end of our problem. We were supposed to be determining the measure, figuring out how many degrees each of these arcs is. And so 4 times 30, if I plug that back in, would be 120. So this would also be 120. And then 2 times 30 would be 60. And this guy would also be 60. Okay, so pause the video, give the U try your best effort, and then come back and let's talk about it. Okay, so I noticed I have a triangle on the inside, and 2 sides of that triangle are the same. 2 sides are congruent. This is an isosceles triangle. And so when I notice that, that means that the part of the circle that that chord is cutting off, that arc that goes with that chord, since the chords are congruent, the arcs will be congruent. So that'll also be 7x on the left. So then when I go to solve this, all the arcs add up to 360. So 7x plus 7x plus 4x adds up to 360. So that's 18x. Divide by 18 to get x by itself, and you get x to be 20. And then we just plug that back in. 4 times 20 is going to be 80. 7 times 20 is going to be 140.